Let's take a look at command line basics, displaying a calendar of the current month. At the command line, there is a simple command that you can use to display a calendar of the current month. Cal. Let's take a look at command line basics, displaying the current date and time. At the command line, there is a simple command that you can use to display the current date and time, the date command. Let's take a look at command line basics, PWD. PWD is one of the simple commands that you need to learn. PWD stands for Print Working Directory. This command gives us the location where we're currently located in the directory structure. Let's take a look at the manual page. PWD prints the name of the current working directory. There are a couple of options which you usually won't need to use. When we run PWD currently, we see that I'm in my home directory. We can explore other places in the file system and use PWD to identify where we are. Let's use the cd command to go somewhere else. Let's try a few more. You'll see that wherever I go, I can use PWD to find out the location where I am. Let's take a look at command line basics, using exit to end a terminal session. When you are done at the command line, it is good practice to explicitly terminate your bash terminal session. This is done using the command exit. After you execute this command, your bash session ends. If you were connected to a remote server via SSH, as I was here, executing the exit command also terminates your SSH session. Let's take a look at command line basics, using up and down arrow keys to navigate the command history. Let's begin by running a few simple commands. We'll start by running a command to see the current date and time. Next, we'll print a simple message. And next, let's display a calendar of the current month. When working at the command line, it is likely that you may want to run a command again. Bash provides a simple mechanism for navigating the commands that you have used recently, the up arrow and the down arrow. Pressing the up arrow will instruct Bash to recall the previous command from the list of recently used commands. Let's try pressing the up arrow. As you can see, the most recently used command now appears. Let's try pressing the up arrow again. The next most recently used command, which in this case was echo, now appears. Let's try pressing the up arrow again. The next most recently used command, which in this case was date, now appears. Just as we can use the up arrow to navigate backwards in time through the command history, we can also use the down arrow to navigate forwards in time through the command history. Let's try pressing the down arrow. Doing so takes us forward one command to the echo command. Let's try pressing the down arrow again. Doing so again takes us forward one command, this time to the cal command. And finally, let's press the down arrow one more time. Doing so takes us back to an empty command line. This corresponds with where we were before we first pressed the up arrow. Let's take a look at command line basics, using left and right arrow keys to navigate within the current command. Let's begin with a command that displays a simple message. After entering this command, what can I do if I want to change what I just typed? One option would be to delete what I typed using the backspace key, and then type something else. However, there is a more efficient option. By using the left and right arrow keys, I can navigate backwards and forwards within the command as I type. Let's take a look at command line basics. Makedir. Makedir is used to create directories. After using Makedir to create a directory, we can use the ls command to verify that that directory was successfully created. Let's try again. This time, let's ask Makedir to be verbose. By calling Makedir with the -v flag, Makedir prints a message for each created directory. We can, of course, still use ls to verify that the directory was created. Makedir can also be used to create multiple directories at one time. If you attempt to create a directory and a directory with that name already exists, Makedir will produce an error message. In the previous examples, we created directories directly within the current working directory. It is also possible to use Makedir to create directories elsewhere. This command creates a subdirectory called edu inside the src directory. This behavior can be extremely useful. However, be advised that if the parent directory does not exist, Makedir will produce an error message and will fail to create the subdirectory. This command failed because the examples directory doesn't exist. There's a solution. Let's take a look at the manual for Makedir to find it. The -p flag instructs Makedir to make parent directories as needed. The -p flag can also be used so that makedir doesn't complain if the directory already exists. Recall that we already created a directory called bin. As we saw earlier, if we try to create a directory that already exists, makedir will normally fail. But by calling makedir with the -p flag, makedir will silently succeed. In all of the examples so far, we've asked makedir to create directories within the current working directory. We can alternatively call makedir using absolute paths. Makedir is an essential Linux command that you will use frequently. You should practice using it to create directories in your current working directory and elsewhere. While you may never use the -z or -m flags, you should learn to use the -p flag. Let's take a look at command line basics, using ls to list the contents of the current working directory. ls is one of the most commonly used commands. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. We can now see that this directory contains 5 other directories: baz, foo, homework, kenlm, and Zork. Let's navigate to another directory. And use ls to view its contents. We can now see that the current working directory, kenlm, contains a number of files and directories. Now, let's use cd to change to a different directory. Now, if I run ls with no parameters, it's going to print the contents of the current working directory, which is /user. In conclusion, invoking ls with no parameters will display the contents of the current working directory. Let's take a look at command line basics, using less to view text files. When working at the command line, it is likely that you will commonly want to view the contents of various files you were working with. There are a number of programs you can use to accomplish this goal. One of the most widely used programs for viewing text files is less. Like many programs you will encounter, the name less is a play on words. Less was developed as a more fully featured replacement for an earlier text viewing application whose name was more. Less can be used to view the contents of text files. Notice that unlike on Windows, on Linux, file extensions such as .md, .txt, .zip, and .py are not meaningful. Even though readme.md has an extension, it is still a plain text file and can be opened by less. Less can be navigated, page up and page down, using various key shortcuts, including space to page forward and B to move backwards. To exit less, press Q. Less has lots of options. One helpful option is the display of line numbers. This option can be enabled with the -N flag. Notice that if necessary, less will wrap lines if the line is too wide to be viewed on the current display. Line 10 in this file begins here, but continues through here. This line is marked as line 10 throughout. Let's take a look at some other files. Here is George Washington's inaugural address. And here is Johnson's. And here is Obama's. The text files don't have to be in English. Less is capable of displaying text in other languages. For example, here's a Swadesh list for Russian. Less can also open more than one file at a time. When using less to view multiple files, the command :N is used to navigate to the next file. And the command :P is used to navigate to the previous file. Less is one of the most commonly used programs you will encounter when using the command line. It is well worth your while to learn how to use it and to learn some of its more commonly used shortcuts. Let's take a look at command line basics, using ls to list the contents of a non-current directory using a relative path. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. ls also accepts an argument. When I provide an argument to ls, it will list the contents of that directory rather than the current directory. So, here we see that there are a number of files and directories within the kenlm directory. If we want to see the contents of one of these subdirectories, one approach would be to use cd to navigate to that subdirectory and then use ls to view its contents. However, there is a faster way. Let's go back to the home directory and try the faster way. Rather than calling cd and then calling ls, we can directly call ls, providing the directory as an argument. In the above invocation of ls, we provided a relative path, kenlm/include, as an argument to ls. After doing so, ls listed the contents of the specified directory. We can also call ls using other relative paths, including those that make use of dot and dot dot. Recall that dot dot refers to the parent of the current working directory. In this case, the parent of the current working directory is kenlm. Let's try another. In this case, dot dot refers to the parent of the current working directory, kenlm. And dot dot slash util refers to the util directory that is within the kenlm directory. Let's take a look at command line basics, using ls to list the contents of a non-current directory using an absolute path. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. ls also accepts an argument. When I provide an argument to ls, it will list the contents of that directory rather than the current directory. So here we see that there are a number of files and directories within the kenlm directory. If we want to see the contents of one of these subdirectories, one approach would be to use cd to navigate to that subdirectory, and then use ls to view its contents. However, there is a faster way. Let's go back to the home directory and try the faster way. Rather than calling cd and then calling ls, we can call ls directly, providing the directory as an argument. In the above invocation of ls, we provided an absolute path, /home, /lanes, /kenlm, /include, as an argument to ls. Let's take a look at command line basics, identifying and understanding symbolic links. Let's take a look. So far, everything looks normal. User bin Python is a file. More specifically, we can use this file to invoke the Python interpreter. Let's look more closely at this file. In the above invocation of ls, we used the -l flag to direct ls to use the long listing format. Notice that in this long listing, there is an arrow. The arrow means that user bin Python is not a regular file. Instead, it is a symbolic link that points to another file. In this case, user bin Python points to the file Python 2.7. We can confirm that user bin Python is a symbolic link by invoking the program file. File can be used to determine the type of a file. This confirms that user bin Python is a symbolic link. Let's take a look at user bin Python 2.7. We see now that user bin Python 2.7 is an actual executable file. So, when we call Python, the system redirects our call so that Python 2.7 is called instead. Now, let's look at a slightly more complex example. We see that user bin Emacs is a symbolic link to Etsy Alternatives Emacs. Okay, that's a little strange. Normally executable files are located in user bin, not in Etsy. Let's take a look at Etsy Alternatives Emacs. We see now that we have another symbolic link. Etsy Alternatives Emacs is actually a symbolic link to user bin Emacs24x. So, when we run user bin Emacs, the system redirects our call twice. First, to Etsy Alternatives Emacs, and then finally to user bin Emacs24x. In conclusion, symbolic links, like shortcuts in Windows and aliases in the Mac OS, provide a mechanism for referring to another file. Symbolic links can be easily identified by using ls with the -l flag, and also by using the file command. Let's take a look at command line basics, using ls to view hidden files. If I run ls with no arguments, it will display the contents of the current working directory. We can see now that this directory contains 5 other directories: Baz, Foo, Homework, CanLM, and Zork. However, this directory actually contains a number of other hidden files. By default, ls ignores any file whose name begins with dot. We can force ls to display these otherwise hidden files by using the -a flag. As you can see, when we invoke ls with the -a flag in the home directory, a number of hidden files can be seen. Let's take a look at command line basics, using ls with additional options. If I run ls with no arguments, it will display the contents of the current working directory. We can now see that this directory contains 5 other directories: Baz, Foo, Homework, CanLM, and Zork. There are a number of additional options we can use to configure ls. One commonly used option is the -l flag. The -l flag